Welcome to this episode of the APL Show. I'm Adam Botsevsky.
And I'm Rich Park.
And we are going to go into the main content, which is our reaction video to this video that we're about to play. Just a couple of announcements. First thing is you can actually reach us. You can email us on contact@apl.show, which also means you can go on our website, apl.show. And then for some APL news, the APL problem solving competition, the 2023 round, has just opened. Don't worry, you've got like half a year to do your submissions, and an experienced APL can solve everything in one day. So you even have time to start learning APL from scratch and still participate and win. People have done that before.
Yep, more than once.
And so if you run out of problems on the problem solving competition, then you can head over to a site called Katis, or it's open.katis.com, and they host both coding competitions and just challenges in general. They actually have a commercial side to them where they verify people's programming skills for various companies, institutions. But they have this open Katis where they have lots and lots of competitions and lots of individual questions, and you can compete against others. And they have now added APL as one of the systems supported on their backend, which means it gives you instruction and input-output works correctly and so on. You can participate there.
Yeah, I had a bit of fun. I did one problem just to see if I could get the input-output working. It was a bit fiddly because I'm stupid, but it was yeah, got it in the end. Yeah. It's the each time you do a quote quad gets, that's one line of the input. That took me a moment, right? It's not like you read a file or anything. You have to take.
There's a tutorial in their menu, and then it will say how the input-output works. It's a stilted way of doing it in APL, but it makes it fair for other languages, and APL will be shortest anyway.
Yeah, right. No, it was still it was one line for obtaining input, one line for solving the problem.
I did one where you had to loop, so it's 2 lines for the loop of gathering input, and 2 lines for catching the error condition when there's no more input, and then 1 line to actually do the work, which is short. So, and then coming up in just a couple of weeks is the APL Seeds. It's on the 22nd of March. You have to sign up for that. We'll have a link to that as well in our show notes and video descriptions and so on.
5 talks. You, me, Stefan Kruger, Josh David, and Richard Savini. Don't know if I got his name right. Should ask him before the day. Yeah, some stuff about APL and getting started, and sort of thinking in APL, and then some stuff that's more sort of application focused, like how do you actually do real stuff? What do people actually do?
And even if you're an experienced APLer, you might want to send some people to have a look. It's really intended for introductory level. It's not a conference of people showing off what they do in APL advanced stuff. It's to get people interested and inspired to use APL. So looking forward to that. Then for those of our listeners who are listening to this as soon as it comes out, on Sunday, the 12th of March, there used to be this recurring meetup live thing called the APL Campfire, where people who had influence on APL's history came and spoke about that. But then I ran out of guests for it, and the series stopped. Now I found Norman Thompson, who has written books on APL, and he's willing to come in and speak about his experience with APL throughout a very long time. That's a live thing. You can participate in that over Zoom. We'll have a link to that in the show notes. And then you have something else, Richard?
Yeah, so this month, it says April 2023, so I don't know how they work out.
It's like car brands.
There's some quad IO. There's some off by one issue with the month printed versus the month that it comes out. But this month's edition of Linux Format magazine, premier open source magazine in the UK, at least. This is one I used to read at petrol station, service stations on the motorway as a kid. You go through the magazines and be like, oh, that one's about computers and Linux and stuff. So that was cool. So I've got a copy of it here. In this month's edition, there is a pretty substantial article about APL. So it's 1, 2, 3, 4, yeah, like four whole pages, talking about APL, a little bit of historical context, a couple of user stories. Got like Ray Cannon, Romilly Cocking featuring in there. Morton's got some quotes talking about, you know, why do people use APL, I guess? Why is it still used and what the advantages and things like this. And Michael Wallace, has he been on Arraycast?
Yeah.
Yeah. K and J programmer also talking about why he uses APL. So that was really cool. Cool to see.
It's mostly factually accurate too.
Yeah.
Nice for a news article.
Yes. So yeah, that's LXF 300, the big 300. You can get it. You can go on the Linux search Linux format, go on their website, and you can buy a copy. Or it's in. I don't know if it's still in many newsagents. Don't look for physical magazines these days, I must say. So most people, I think, get it on a subscription delivered to them. But anyway, it was cool to see that.
Might be able to find it in a public library. Could you imagine they would have
You
that?
definitely will. I mean, there are a number of libraries in the UK that have a whole thing where it's like they get everything that's ever published that they can. At least I think that's one of the Oxford things, right? You can like go in there and request a Mr. Men book, you know? They all have it because it's been published.
Yeah. Okay, so again, we're doing something new here. A reaction video to another.
We probably should have said at the beginning, you know, although we're showing the video and stuff, if you're listening to this, it's a talk with I don't think it's too heavy on the visual content, so you should be able to follow along, listen along, even if you're just listening.
If you like this type of content, or if you do not like this type of content, feel free to let us know, so we have an idea about what our listening crowd wants to have in the future.
Anyway, this is a talk from. I don't know, the video was published relatively recently. I'm guessing it was the conference
a month ago. It was published a month ago, but when was the conference? Last year?
Maybe last year. An Australian data engineering conference, like what does it say? Yeah, community conference for people who are doing stuff that we consider APL's wheelhouse, right? Real world problem solving about data and using computers. That seems to be the topic of the event that this talk was given at. I need to. Can you scroll down on the thing because then I can read. Oh no, you sent me a comment about it anyway. Yeah, it's called DataEngBytes, whatever you like. Australian software data engineering conference, and Xuanyi Chew is the name that I'm butchering of the person who's given the talk, and the premise is change the way you think, change the way you write, I guess, your code, or in general, change the way you think about problems, which is obviously very on brand for the APL show, where we talk about notation as a tool of thought. And, you know, he also talks about APL in there, so it seemed appropriate to try to do a reaction to this. We don't know how it's going to go. We haven't done reaction video before, but you know, the format is laid out for us. So I say we just get into it. We'll probably, we'll see how it goes. I don't think there's much more to say.
So far, I'm with it.
I hope those are nice sounds. I hope those come through okay in the recording of the shared thing.
We'll see.
Hi. You
could always splice it on top.
Today I'm going to talk about how we solve problems, right? And why we should use more diverse and varied notation when it comes to our data engineering problems. So my talk is going to be a bit different from the rest of the talk you've seen today, and I hope it does give you a bit of something to think about.
The slide says on notation or YAML must die.
Okay.
Not a fan of YAML. Actually, you hit some.
You're a human being. We're all human beings, and the best thing about being human.
I mean, we'll get to this in a second, but I do remember that he had some like a list of recommendations of like here are some commonly used tools, and here are like supposedly better versions of them. I wrote that down in my Obsidian vault full of notes, but I haven't actually spent the time. I think I looked at the first couple. you know, we'll get to that, I think, in detail when we get to it, but I thought that was interesting and pretty useful.
Living can solve problems, right? The difference, the thing that makes us different as human beings is that we can solve problems, and then we can transmit our solutions.
Controversial.
Via a long life
in the animal kingdom.
And monkeys and primates, they can do the same thing. They can transmit solutions to other birds, other primates.
Okay, no, he's shouting at the animals. It's fine.
Only we humans write things down, we make videos, and we document them for other human beings. So that's what my talk is all about. So
I don't know if animals write things down or not, because you might not perceive the
language
transmission, like scent markings and things, but I'm pretty sure
scent markings count, yeah.
Yeah, I'm pretty sure that no animals make videos and put them on YouTube.
I'm waiting on that animal podcast, yeah.
We solve problems, and as in general, we human beings have an algorithm for that, right? It goes something like this. We first simplify the problem, and we do this by very simply breaking down the problem into smaller components. And this is actually very useful for the kinds of problems that are, well, 99% of the problems that are compositional in nature. And for the rest of the problems, we just solve a simpler version of that problem, right? And then the next thing we do is we solve the smaller problems. And the core of solving problems is that we are establishing the rules for how the elements of the problems can interact with one another.
So this makes me immediately think of APL anyway, because I very much think of the APL primitives as these solutions to these very simple algorithmic problems, and then you just piece them together in order to make your bigger solution.
Right? Yeah. So in well, I guess conventional computer science education nowadays, like decomposition is one of like the early skills that you're teaching students, and they're using whatever traditional languages, Java, Python, something. But there is this sort of interesting question that I don't think there's any writing that like lays it out in this sort of in these clear terms, or this clearly about. Well, I guess it just depends on the language and the constructs you're provided, right? But when you break down the problems, you're doing so to get to some point at which, okay, I know I can express this thing to the computer to get it solved, and then you know APL, sometimes you're able to jump to that step a little bit sooner than you might be. I mean, that's getting possibly less true with certain types of functional constructs, but depending on the type of problem, it's still pretty true that it's what, I don't know, some people have argued as like, as opposed to decomposing and then abstracting. No, instead of well, I've heard it expressed as, instead of decomposing quite to that level before you can express, that you're able to more directly express solutions in APL, which is sort of, again, true for some things. Maybe it's just as awkward for other things. I'm trying to think of an example, but I guess I can think of that while we keep going, because I haven't got one to hand really.
So let's keep going.
Reverse an array, one glyph.
These rules are.
But a lot of languages have that as a primitive anyway.
Rules are invented, and once we've done that, we solve recursively, and we combine the solutions upwards, and that's how we solve problems, right? So, as a cultural species, you humans.
What if we have no idea how to attack the problem? Like, it might be some kind of algorithmic thing where we don't know how to get there.
It's the scientific method then. You take a guess, and then you either think of the implications of the guess, or in the case of computers, it's generally quite easy to just try it. And then you compare the results with, well, I guess in science it's experiment/experience, and in computing it's like, what did you want to happen? Okay. But guessing is the common first step there, I'd say. Like when you don't know.
Expressed mental states in long-lived mediums for millennia. And that's why we've got songs of love. You've got poems of joy and paintings of depression, right? And problems are also mental states. And through the millennia, we have gathered a body of knowledge on how to represent these problems in forms of diagrams, equation, and code. What you see up here is something called a Wardley map. And it's very useful for exploring problem spaces. And on the left, you have the code representation of the Wardley map. And the code representation is mainly the work of my mate Olivier. And because the map is actually represented as code, it gives you, when you manipulate the code, it gives you more ideas on how to manipulate the map. And manipulation, I think, hints at the...
I gotta say here, this is a little bugbear of the recent conversations we've been having about, like, where I've tried to bring up visual representations of code, and people have been like massively
problems that in their brains, out of their body. What I'm referring to is language.
What's a polite phrase to to save people's reactions to that?
So I want to be a bit open-minded, right? When I say language,
I think diagrams are useful.
Python,
That's just me.
Java,
I don't know.
or English and Mandarin. No. When I say language, I mean the structure, the things that you can describe with rules, right? Which we call grammars, and the elements of the problem, which we call vocabularies, right? These are all languages. So let me give you an example. In a database, you have a column that says the values in this column cannot be null. That's a rule, right? And the values that actually go into the column, those are the vocabulary of the language, right? Your Airflow DAGs are a language, right? But they're an unconstrained language. And if you don't constrain your Airflow DAGs, what happens is you can have...
What is that? Airflow DAGs.
And things explode. And this talk is mainly about written language. And when I say writing, I mean the whole spectrum of reading, and writing down the symbols and manipulating your thoughts, essentially manipulating your thoughts outside of your body. And this is...
we can actually go, right. This is the... We have the technology.
And things explode, right? But they're an unconstrained language. And if you don't
just missed it a little bit.
I saw the word Airflow DAGs. Airflow tags?
Mutually dependent tags are a language, right? But they're an unconstrained language, and if you don't constrain,
we also have the technology to search what Airflow tags are. But we'll keep this going because there's a lot of preamble before he gets to showing something.
Mainly about written language, and when I say writing, I mean the whole spectrum of reading, and writing down the symbols and manipulating your thoughts, essentially.
Okay.
Outside of your body, and this is.
We actually have this. Airflow DAGs, DAG. So the transcription was right. Okay. Or directed acyclic graph is a collection of all the tasks you want to run, organized in a way that reflects their relationships and dependencies. So that's kind of neat. So it looks from the images I'm seeing very akin to, it's like flow charts, but I think there's maybe a bit more to the, I mean, this page that comes up is from the Apache Software Foundation, so I'm guessing there's like a bit more to the syntax that allows you to like define the relationships in meaningful ways, a bit like no, I don't want to make that comparison because I literally have no idea if I'm really reaching at that point. I was going to say about semantic web, right, where you're like attaching metadata that about like human understandable but also computer understandable meaning to things, and then allowing the relationships to propagate that way. But I don't know if it's that dynamic, but I assume you have to like make the relationships yourself. But anyway, it's a real Airflow DAGs. It's not just like gobbledygook. It's a didn't mishear that. Just didn't know what it was. With DAG, my DAG. Yeah. The example's a bit. I'm not going to go into it now because I have no idea. But yes, so it looks like it's to do with like describing processes and stuff in a general way.
Manipulate your thoughts outside of your body. You're engaging in system 2 thinking. So, having explained the problem with problems, and let me just share with you what I've been roughly thinking about.
Right, you want a notation you can manipulate,
to build an AGI,
which diagrams are also good for, because we're like...
But they're hard to manipulate in a systematic fashion.
Yes,
One of the various things that I've done,
they're good for the exploration stage though, but you usually just throw things away and then make a new one based on your experience of what you just did.
And also for explanation, right? To tell others what's happening.
Oh, they're great for that, yeah. Once you've figured out what the idea is.
Very simple. Are there ways of writing down neural networks that can lend itself to a better understanding of intelligence? And speaking of neural networks,
I don't know, we should link to Rodrigo's Dialogue 22 talk as well in the show notes, because he has a nice
a taste of what this talk is about.
But also his video series.
Yes, a video series as well. I was going to say specifically, Rodrigo has this talk. He's talking about having implemented convolutional neural network of a particular architecture called a U-net, and then the diagrams are all in a U shape, so they're kind of like from the left to the right, going down, curving around, and then up in terms of the diagrams, and how that was translated into this kind of, as he explains it, fairly intuitive looking grid of the stages.
Equations, the way Einstein would think about linear algebra, you start spotting the weird optimizations that you can do, and you end up with a much faster neural network in the end. And all this by virtue of writing your neural network down in a slightly different way. Now, these are all rather mathematical notation. And from my experience dealing with humans, mathematical notation kind of scares people away. So the other thing that I've been doing is to represent neural networks in a form that is familiar and comfortable for software engineers. And so I did it by starting with
this doesn't scare people away.
All right, I find this an interesting
machine learning, ML.
Like a talking point comes up a lot. Obviously, you get it in school non-stop. If you like have any sort of aptitude or interest in maths, well, even if you don't, I think everyone has like experienced people saying like, "Oh, I can't do maths, don't like maths," and that's not anything. I don't, I don't think we have the scope or capacity in this episode of this podcast to really delve into why that is. But I think it is interesting, and yeah, looking at this example. So he's talked about, okay, he's shown some examples that are very terse, symbolic mathematical notation related to neural networks. And now he's contrasting that with more verbose looking, pseudo-English vocabulary. It's got, and it's...
This is not a real programming language?
Well, it probably is. I'm saying in terms of like the vibe of it, right? And this is what like conventional languages, programming languages look like. The vibe is the keywords are all based on English terminology for the most part, like often abbreviated.
Looks like a type of Lisp.
Yes, and it's also got a prompt that says lambda greater than, which implies some kind of functional
I'm sure
programming
people will
language.
know what that means.
For example, to read it out, let x equal sign, that's a symbol, matrix, open parenthesis 2, comma 2, close parenthesis, of float 32, within it, open paren, glorot n, close paren. So, obviously, you could, apart from like a lot of symbols having one syllable vocalizations, you could argue that like vocalizing any notation is a bit ham-fisted and awkward. It usually is. Pen and paper and reading is usually more expedient for most people, obviously notwithstanding like people with visual impairments who have to listen to things, but
or feel them with their fingertips.
Yeah, all right, well, feeling's probably as fast as reading if you're good at it. Or like comparable speeds, I reckon. I don't know, but that's just a guess. But yeah, I mean, people. I think, maybe it's changed nowadays, but I suspect not. I suspect it's getting more this way. People react in a similar way to looking at code, traditional languages. Like it still seems enigmatic and weird. The only thing that probably makes it seem less scary on the surface is like I said, the use of word-like things in the language make you think that maybe you'd have an easier time grasping it.
It's just a sense of familiarity, right?
That's yeah, exactly right. At the end of the day,
because we do use lots of symbols, even when we write in natural languages,
right? Or even like on signs and things like that, and
yeah.
And whether you're learning, mathematics using traditional mathematical notation, or whether you're going to learn programming, I feel like there's a similar journey of like slowly picking up small pieces at a time, and then sometime later when stuff has kind of had a chance to really stew in your brain and settle down and sediment in nice little crevices of your cranium, you've you come back, you read it, and you're not scared anymore. You're more familiar with it, like you say. So,
but his point here is he's saying, well, you can. I mean, the code example he is showing here is not as particularly readable to me, but I think it's actually very simple. There's just some comments there that I verbose, but the code itself is extremely simple.
that's true, yeah.
But that's not the point. The point here is he's saying, oh, things can look simple, but through abstraction, just don't look under the lambda. Right? So if you actually look into what's below the abstraction, then things aren't so simple anymore.
Right, you can always solve a problem. You can always say I solved a problem in one line of code if you wrap everything in a function.
Of course, every programming language can do this.
Yeah, exactly. So it's just deciding what level to have that abstraction. Anyway, I've run out of thoughts for that.
If you're familiar with Haskell, what happened?
I don't know, maybe the click went through twice.
And then I tried an algo descendant language, which is like Go. I actually presented this as a generic version of Go before. And then finally, I built a surface language for Gorgonia that is essentially an APL. Who here has heard of APL?
I have.
Showing the classic John Scholes edition Game of Life one-liner there.
Even though it has nothing to do with the other code that he showed.
But it's become the canonical. Look at this weird stuff. Can you believe that this is a programming language? Oh, look at that. It's line noise. It's so weird. What does this mean as a plus? And this is like carrots and.
The generation step is the entire program.
To be fair, when I first saw this, it's like, and you watch the video, you're still like, and then like, I don't know how long it was into learning APL. It wasn't that long before I was like, oh, actually, that's not very complicated at all. When you learn Game of Life.
When I first saw the Game of Life, it was like shrug.
You like shrug, right? Because you already knew APL, right? Yeah.
So now now he's showing something that it actually goes the other way around, right? Whereas people might see traditional programming languages and go, "Oh yeah, that looks familiar," because lots of English words there, but they don't actually understand what's going on. Here, he's showing a code example of this language he has implemented, I think, where I immediately go, oh yeah, this looks familiar because this looks like APL, and then I go, wait a minute, I don't actually understand what this is.
There's like a delta. There's quad question mark GN.
Yeah, no idea. Quad question mark GN 22. Question mark U 22, and those get assigned into X and Y, I suppose, and then he's doing an inner product X plus times Y.
That's good. That's APL, yeah.
Assign that to Z. So far we're with us, but then what is lowercase delta
X equals Y
equals Y? Check the partial derivative of X equals Y. So
is does delta bind tighter to X then?
Maybe.
Yeah.
So there's some kind of meta notation thing. And what are those quad question mark things?
Yep.
We'll see.
Mysterious. And it's here I want to stop for a bit and do a deep dive into notation changing the way you think about a problem.
Here we go.
The APL that I developed is called Inigo. I meant to open source it before today, but things happened, so it will still eventually be open sourced. And you might notice it's styled a bit weirdly. That's because Inigo stands for...
Oh, if we can find that, we should link.
It's styled with uppercase N, uppercase I-N, lowercase I, uppercase G, lowercase O. So it stands for Iverson notation in Go.
Iverson notation in Go. I'll talk about this Iverson bloke in a bit. And when you have a language called Inigo, you clearly have to have an interpreter called Montoya who threatens right?
Do you know this reference?
No.
It's it's called Inigo. So his like prompt when you start the program says, "Hello, my name is Inigo Montoya. You killed my father. Prepare to die." That's is it The Princess Bride, or it's an old movie? The guy called Inigo Montoya.
Wait, so it's so Inigo like that is Iverson notation in Go, but it's actually a name also.
Yes, yeah.
A materializer of names that otherwise yield ought.
Is that an acronym for like name generator?
I think so.
That otherwise
It's
you'll.
called the backronym when you do it like that.
Yes, yeah, it's a good. I like this backronym. Yep.
Bit of history. I originally used Inigo as an exploratory vehicle for a better notation for differentiable programming, right? Then earlier this year, I sort of temporarily lost the use of my left arm. I couldn't type without the arm feeling like it was on fire or electricity going through it. So I thought to myself, hey, why not code in APL? Because you are going to be typing symbols, you're not going to be typing words, there'll be fewer things to type, less pain. So I got someone from Sri Lanka to help me finish the first version.
That's actually a good point. You know,
Yeah, less
for
RSI.
RSI, yeah. Even if people say, well, it takes longer to type these, or like you have to contort your hands and so on, but it's actually less typing.
Overall, yeah.
I used to commute on the tube in London. That's the underground train thing, and it's very often crowded. I had a small laptop, like 14-inch or something, and certainly could not get a seat. But I was actually able to be productive there by balancing my laptop on one hand and then using the other hand to type one character at a time. Yeah.
And after using it a bit,
yeah,
what
savage.
I did was that it changed the way I think about solving problems. So now that I can use my left arm again, I started work on V2. So another note about Inigo is that it's a bit different from the other APLs like Dialog APL or GNU APL. There are more symbols, and these symbols are
Shout out Dialog.
And also different is the fact that
Big up.
Trigger differentiation and get the partial derivative of a variable, just that. So that's also part of the reason why it's not.
Yeah, automatic differentiation. People have talked about that. I haven't seen. I think there's some old papers, but I haven't seen anything like.
Yeah, Iverson had
usable.
he wrote some functions for doing that. And there's some books I've seen that. And
in
then
neural net land, it's very in vogue.
Okay, and Jay used to have, I think, some of that. I think they took out because it wasn't so reliable. It was better suited as a library. It was implemented in J underneath the covers anyway.
Yeah, so. It would make sense to me. You'd want that. Well,
so
but that would
be
a library.
My side projects. But let's get to the meat of the talk. As I have alluded to earlier, by simply switching my programming language to APL, I changed the way I think about solving problems. And I think this is very
the one side of the APL Marmite coin. People either like so turned off they never actually learn it, or they go, "Oh, wow, it changed," or they learned it for a job in the 70s and 80s, and they got a bitter taste from looking at like people's, having to maintain people's like terrible old code bases and stuff.
So here you're showing the APL logo with a slogan below, "Think Different," which is from Apple. Well, so if this doesn't get him sued, I don't know what will. You know, by the way, why Apple uses the slogan "Think Different"?
No, I don't know that.
Oh, well, it's a reaction in itself to IBM. IBM's slogan is "Think."
And Apple is Think Different. And APL, we're gonna have to come up with something else, even though that's kind of our. I mean, Apple's not even that Think Different, is it? It's like think like every other Apple user. That's like why they have a monopoly in the US, and that whole thing about the is it green text boxes or whatever? In this, this is like a huge thing in the US where people, iPhone users hate Android users because if they text someone. And they still do a lot of texting, whereas in Europe it's like all moved to online services like WhatsApp, so no one notices this in Europe. But in America they're still using like their carriers' text services for the most part. And if you text an Android user from an Apple device, the messages from the Android device have like an uglier green text bubble instead of the nice pleasant Apple, one from iPhone users. So it's like causes this whole tribalism of hate Android users because and the images are worse quality, but it's also Apple's fault, right? It's not.
But Android is right. Apple does take a whole different approach to marketing and features, and
that's true. It's Think Different to other things, but like within the Apple ecosystem, it's also very cohesive and stuff.
Yeah.
But yeah, no, it is different.
Okay, so now he's showing plus dot times in a product. That's definitely thinking different.
Go on, what's he saying about it?
These symbols, what do they do? In APL, you think of as
me whenever I look at APL code. 3 symbols, what do they do?
here, plus, dot, and times. Now, we all know what plus and times do. The only difference in APL is that
Great,
also
2/3 of the way there, haven't even done anything.
1, 10, 100, and 1,000 are arrays, and when you multiply them, you're basically multiplying them element-wise. Side note, I also want to talk about reduction for a bit because it's actually important to how in the product works. Let's say you've got an array 1, 2, 3, 4, and you want to collapse this array down into one single number. What do?
It's in the classic APL intro.
We call this summing. Everyone's familiar with this?
Element-wise operations, reductions. Some will go into inner product. Basically, from there, you're running, aren't you?
Plus into times, you get a product. 1 times 2 times 3 times 4. And the reason why I'm introducing reduction here is because it's actually relevant to how inner product works. So let's go back to this. We know what plus and times does. What does the dot do, right? Because it's pretty magical what the dot does. And magic is not good for software development. So this is what the dot does. The dot is another function that considers the left and right
operator.
Function. And so it applies the right function first and takes 2 arrays and multiplies the results together. So you've got A times B, put them in one cell. B
I gotta say, I remember this now
F into 1.
from when I watched this, a couple months ago, and I gotta say, he is demonstrating a really good understanding of inner product and then also in high rank arrays in a way that I think a lot of APLers even, and myself included, don't take the time to really grasp. Like a lot of people use plus.times as kind of a shorthand for plus/vector times vector, because that's a super easy thing to grok, to internalize, and it's super intuitive. And then you're aware that it works for higher rank arrays, but you don't.
But it's not just a reduction on the scalar application.
No, it's not. In fact, I saw, and again, if I was doing something around this soon, I would go back and look at this. But the expression of inner product in terms of rank operator is a nice way of explaining it as well.
It's interesting. That's not how my father explained it to me at all. He explained it very visually and geometrically, which actually makes me react a bit to this. So now he's showing on the left A, B, C as
a row.
Horizontal, as a row, horizontal fashion. And on the right, he has D, E, F in a vertical fashion. And that's transposed of how I learned it. I thought it as the left argument.
This is how I learned it in, I did AS, so at half an A-level further maths, and there was one module, I think it might have just been called vectors and matrices. And we definitely learnt doing it in a product multiplication like this.
But not transposed from this?
No, it was a row on the left and a column on the right, as far as I remember.
Okay.
But it is much of a muchness. You just tilt your head and it's,
Not really over transpose. But hold on. So, but now these are just single row, single column thing. But if you got multiple of them,
well, yeah. So you're now doing, when you've got multiple of them, you're doing first row, first column, that goes in the corner. Then first row, second column, that goes next to it, top, middle. I'm doing a 3x3 example here. First row, third column, that goes, first row, third element. And then next, and then you do the second row, first
the second
column.
row of the result takes the rows.
The second row,
so it follows the left argument. So I guess you can see it both ways. But I guess I was,
or at least I'm describing it the way I learned it. Yeah.
I was seeing the right argument as being the principal one that decides. So here, in a sense, from the arguments to the result, the horizontal, in this case, left argument, stays horizontal, and the right argument gets transposed in, right?
That's because in this case you're taking a 3-element vector, I guess, or a one row matrix. Can you do it either way? I don't know how I'd actually. But in APL, I mean.
But anyway, if you transpose the arguments, then it will just be the opposite, right? Then the right argument is the one that stays in its shape, and then the left argument is the one that gets transposed in.
Right.
Anyway, continue.
Yeah.
And then after that, it will apply the left function And what does it do? It collapses, reduces the array. And now you can apply this to matrices as well. So the inner products of the blue row and the...
Right, this diagram here he's showing, so he's got like on the left a 2 by 3, 2 row 3 column. Actually, yeah, can you pause this and send it back 10 seconds? Two rows 3 columns, 2 by 3 on the left, and on the right it's got 3 by 2. So they conform in an inner product, and then the result in the bottom middle is showing a 2 by 2 matrix. And then he's highlighted what we were just trying to describe here with the first row of the thing on the left, the sort of flat one, horizontal one, and the first column of the vertical thing on the right. The plus dot times of those becomes the top left cell, the first cell of the result matrix, and so on and so forth. So
which also illustrates here that the shape of the result of an inner product is the concatenation of the shapes of the arguments, but eliminating the 2 adjacent length vectors.
Slightly hard to tell only because we've got the same number of rows as columns.
Yeah.
No,
but that's actually the case.
Axes, yes.
So, or in APL terms, it's the shape of the result is -1 drop of the shape of the left, comma, and 1 drop of the shape of the right.
Right.
Anyway.
Yep.
And the yellow column would be the green, and so on and so forth.
Just flashing colors.
Yeah, that was really quick.
Our eyes.
Product works.
Well, they say it's that's a nice visualization
really
of the inner product, I think.
After using this for a while, I got this Satori moment, right? Where I realized that each of these symbols are...
Oh, I had to look up what Satori moment is. Pause this, because this is worth...
and just replace them with any...
This is worth explaining if you're listening. You don't want... So Satori moment, I had to look it up because I'm learning Japanese, and one of the tools which I don't use but I've heard of is called Satori Reader, and it's obviously there's some connotation of the word Satori with like illumination and whatever. Well, you go on the Wikipedia article for Satori, Satori, is a Japanese Buddhist term for awakening, comprehension, understanding. It's derived from the Japanese verb.
So an aha moment.
Yes, it is an aha moment.
And now he's showing something that looks like an Asian style emoticon.
The cow emoji. Well, yeah, they're called cow emoji in Japan, but I don't know what they're called elsewhere.
It's and.
Yes, with a dodgy font.
Yeah, it was kind of handwritten.
That was one thing in the very last thing that I noticed in. So recently, internally, we've been reading old APL papers. Well, Iverson notation ones, like pre-APL. Looking at examples of notation and stuff that was written about that, and there are a lot of relatively low-level examples, right? Things that are about, because it's to do with like describing a computer system, right, and processing instructions and doing actual low-level stuff. But there seemed to be like an inordinate number of inner products in those papers, I think, compared to what I see in like regular APL code these days. So many inner products, like loads of stuff is expressed in like all kinds of different ones as well. I thought that was interesting.
That is true, yeah. Oh, there's also a difference. I can go back to that another time. There's a difference in definition of the inner product, whether there's an each or not in there. And the definition that he uses doesn't use the each, which actually enables certain things. There's a bit of pity that Dialog APL does
would that have been like not an issue back before nested arrays?
No, because he uses inner products where the right operand is replicate or compress.
I see.
And that you can't do that if there's an each on the function, then it doesn't really work. Then you get a whole bunch of little vectors instead of actually collecting the whole result. So, but we can get back to that another time.
I think so. I think we'll have to. I don't know how much more of this we can get through. I told you how much of this. Well, I guess we've gotten to the part that is really for us, right? In a sense. Yeah. So if we manage to get to the end of this, I guess we can either decide to come back to the rest of the talk in another episode if people are into that, or
yeah, I think we can do about halfway through and then we can stop and then continue another time.
Yeah.
Let me show you an example. Let's say we do an inner product of these two arrays, and the result is 70, right?
1, 2, 3, 4, plus dot times 5, 6, 7, 8.
Left, yes, left function. And instead of plus, instead of using plus to reduce, we use concatenate to reduce. So as you reduce, you're actually recreating a new array. Right now we've got a new array, 5, 12, 21, and 32. Now let's replace the right function. Instead of multiplying, we're going to actually print what it's actually doing. Okay? Sorry about the syntax. This basically says take the left element and right element.
You can find this type of expression often in the APL orchard when people are just getting started.
So I often recommend people to replace functions with functions that show what the result should be. So here he's saying, so you had 1, 2, 3, 4, comma dot times, so concatenate dot times 5, 6, 7, 8, and then of course he's getting 5, 12, 21, 32 because I mean it's essentially just scalar multiplication. Although what he's not showing here is the result being enclosed, whatever. Now he's replacing the multiplication with a function that instead of multiplying just shows left argument and then multiplication sign and then right argument. And then he's putting a comma after that, which I guess that's just for visual purposes. Really what he should have been doing is that it's replacing the comma function with a function that inserts a comma.
Yes.
But he's actually concatenating, which means he gets a trailing comma that he shouldn't have. Anyway, so then he gets a nested result, really, but you can't really see that. It's 1 times 5. It says spelled out 1 times 5, comma 2 times 6, comma 3 times 7, comma 4 times 8.
Right, and implicit. Well, for APL as implicit parentheses.
Yeah.
For each of those.
You could have inserted the parentheses inside the function as well.
Yep.
And concatenate.
Well, should have asked us to
review. Yeah.
Right?
No, it's good.
How the whole process of this inner product works. And if my example hasn't hit you on how powerful this thing is,
this is really nice. This is the type of stuff that I guess we see the likes of what Marshall, Aaron, and Morton have sent to functional conf. And you got
to change your existing solution
programming audience.
The way you solve problems. It gives you confidence in exploring. And more importantly, it also clarifies...
That's a big thing. That's what we were talking about earlier, confidence in exploring. Like, when you don't know, right? And you're taking guesses, but you can, like, without too much effort, figure out which way is the right way to go, and then pursue that further, without being like, oh God, I have to, like, I spent hours writing, well, I mean, sometimes you do, but, you know, writing all of this boilerplate, and now I'm going to take it all apart because I've decided to do it a different way. When you've got a nice notation to play with, then that's less expensive.
So anyway. Now he's showing a fork. Arguments are C and P, C on the left, P on the right, and then the fork itself is times divided by plus that times. And then in the background image, there's like the mathematical formula,
it's Bayes' thing, isn't it? Probability of A or B is probability of B or A times probability
surely
of
this
A
is not the same thing.
Well, we don't know what C and P are related in relation to A, and like if it's P is probability, and then there's two like events.
Maybe if this really means A or B, then surely that's not the same thing as times. It should be A and B.
Let's see.
The probability of, I mean, it can't be probability of B and A times probability of A. That makes no sense.
Well, we don't know that C
and C and P. I'm not sure it's the same thing. We'll see.
Yeah.
This is Bayes'
theorem, right? Oh, yep. Jinx.
The array of conditional probabilities, and P is the array of prior probabilities, right? If you start with the equation in the background, I'm not sure if you can see it, and you start whittling it down.
Oh, it's not or, is it? It's A given that B is true, isn't it? Something like that.
In its simplest form. I would like to see you do that with...
So the vertical bar doesn't mean or, it means...
But of course, not all my code looks like this. most of my code looks like this. And
okay, he's gone from a tacit that times divided by plus dot times,
which was pretty elegant.
Little fork there, yeah, for Bayes' theorem, very nice. To a defin with
way many nested parentheses and nested defins and stuff.
Oh yeah, I was going to say not too many, but actually
it's
yes,
unnecessarily many as well.
Well, only by a couple.
No, but it's also doing unnecessary stuff. Like okay, so we can spell this out, but
yeah, go on.
It's the overall thing. It's better to explain probably what it is. The overall thing is selecting from the left argument. There's a function called CP. It's selecting from the left argument. And then inside that, we start by subtracting the average of the right argument from the right argument. But but he's doing that by saying omega minus, and then the famous plus slash divided by tally fork on omega. But you could have written that much nicer, I would say, even though it's the same length. You could have written that as right tech minus plus slash divided by tally, as a 5-car train.
And then he's
mixing tacit and not tacit for no particular reason. And there's a trailing parenthesis.
Yeah, I don't think that's too bad. But the parenthesis around you could get rid of.
So it's a cumulative sum of the difference between the argument and the overall average on the right. Then he's taking the absolute value of that. And then he's applying a function to it, which is simply finding the maximum, the position of the maximum, the first maximum element in that. Right? So, but again, it's written in a in my opinion, a very awkward style, because what he's doing is he's computing the maximum element value, and then he's binding that as right argument to the iota index of function, deriving a new function, which is a function which always looks for that value.
This should be right tac index of max slash.
That's one way.
And then get rid of all that defin.
Yeah, or you could have done that, yes. Or you could have, if you really wanted the defin, it's just a omega iota max reduction omega.
Yes, actually that's
it's much simpler. But yes, the fork is obvious here. All right, I mean it's actually a hook.
Says the lifetime APLers versus this dude who's just trying stuff out.
Oh, but it's surely unnecessarily complicated here. This is not necessary.
Yeah, but you do. Yeah, it does take experience to spot these things.
But he's deriving a monadic function from a dyadic function only to apply it immediately. There's no reason to even like you can see that.
Oh, right? True. But but I find that with people who come from functional land, they will be composing stuff left, right, and center rather than writing expressions.
I see.
Yeah, I see that. Not just here. I see that in a few cases, and it's typically if people have come from or have experience in functional languages,
right,
rather than procedural ones, or
takes a time
just learn APL
and finds a point in time that something happened that caused the mean of the time series to change, to shift.
The most change the most.
That's the entire function on screen in one line. The equivalent in Python takes about 30 lines of code, and it isn't as obvious.
That can't be true. If you use maps and
list comprehensions.
Yeah, there are
I don't know. How do you do a cumulative sum in Python though?
Math.com sum probably. That's my guess. I don't know. But
okay, no. I mean, so it's the right argument.
Yeah, there's no way that's 30 lines unless you're writing it in pure for loops.
Yeah.
With array, with index, looping over the arrays and then.
Even for the summation, you mean? So if you do one for loop for the
that's what I'm saying. You have to really eke this out to get 30 lines of Python, I reckon.
One for loop for the summation, one for loop for the division, one for loop for the subtraction, one for loop for the cumulative sum.
At which point you've already abstracted each of those away into a separate function that you're calling within the main body.
One for loop for the absolute value, and then we do a for loop to get the maximum of that. And then we do a for loop it's not really a for loop. I don't know how you do it exactly, but whatever. Some kind of loop for the
index of.
Index of. That's only
no, that's going to be primitive on arrays as well, isn't it?
Sure, but even if you were to do that, you could do a for loop and then break out early when you find it.
Yeah.
That's 7 for loops, and since Python uses indentation things,
yeah,
then surely it
7
can't be more
times at
than
least.
eight lines, not 30, but whatever. Okay.
No, 7 times, like 3 per for loop.
Why do you need 3 per for loop? In Python, it's one.
For blah. Oh, can you do it in one, can you? I thought you had to do for blah blah blah, new line, indent, and then do your thing. So at least 2.
Yeah, but it's just a lot of the loops are just for this, in that, for this and that, for this and that, for this.
Yeah, if you're using
maybe, but
the
if you do
in.
Yeah. Oh, I see.
Isn't that a list comprehension syntax? Whereas, like, if you're doing an explicit for loop.
I don't know. Anyway,
no, we don't know Python yet.
I want to see his 30-line solution and then have some Python
yeah,
program
exactly.
look at that. But I mean, I'm sure you can write this in 1 line of Python as well.
Plus, we're being a bit, I'm not against hyperbolic, bad mouthing other other languages in the context of promoting APL.
No, but we have to be realistic, right? This is exaggerated.
Yeah.
Function is doing S1.
Anyway.
Now, when I say obvious, you obviously have to know how to read APL, right? So, clear thinking isn't all. By virtue of having a different notation, right, I discovered or rediscovered some of these things. The second one is a bit cheeky.
Scholemization of dual rediscovery of differentiation by means of scholemization of dual numbers, which is like
this I know from nothing. But I think of great Lobachevsky, and I don't know
what do you got this?
That's a successor, and then you go to addition, and then you go to multiplication, and then you go to exponentiation. Right?
So that's okay, yeah. So that's just like iterative.
Well, these are the levels. It's a evolution of this logarithm thing.
1 jot plus power n is plus.
Yeah, well, we don't have. I mean, we don't have a primitive in APL for successor.
No.
Right. So you're modeling it as 1 jot plus, but then you're already assuming you have plus.
Yeah.
But in J, there's a successor, but
and then you can derive multiple exponentiation from there. That's fun. Yeah. So let's go. Yeah, successor. Yeah. Then
successor, addition, multiplication.
It's repeat. Sorry. Yeah. Successor is just add 1. Addition is repeated succession. And then multiplication is repeated addition, and then exponentiation is repeated multiplication. Right, that's it in words for the listeners, right? And the last one, various isomorphisms that may be useful for. Yeah, okay. Well, that's pretty typical APL. That may be useful for developing neural networks. Iverson calls this suggestivity. Right.
You note so far that I've merely talked about
ideas, suggestive ideas, and you relate things because that looks like that, even though I was doing these two things in completely different domains.
I like to type symbols, and really at this point it feels like I'm flexing. So let me flex a bit more.
And that's why possibly last. Maybe we'll do this as the last flex. But I got one. I got to pause this. I got one. That's the suggestivity thing is definitely why I know Aaron Su is very cautious of like introducing things or using things which are like abstractions and frameworks and things like this, because you lose that ability to see that you're actually doing really similar things in two different ways when you've like embedded them in 2 different names and you're calling them with 2 like semantically different arguments that mean different things, but then under the hood, it turns out you're actually doing identical things. Whereas if you wrote that in raw code, which is not always practical to do, but if you did that sometimes and often, rather,
spot the patterns.
You can spot the patterns and you can see.
Oh, that would be nice if the IDE could do that. Oh.
What? Would like pattern match across your APL code and show you where you've done similar things.
Yeah.
That
may be able to abstract this out or reuse the code.
Yeah, possibly. That sounds like a challenge beyond trivial examples. It sounds like a nightmare.
Who will write small programs to scratch my itch? So for example, when I needed to annotate a bunch of text documents for a machine learning project in the previous work, instead of using external annotation tools, I simply wrote up a small Emacs library and annotated it. Who needs Protege? But that's arrogance talking, right? This solution is not scalable. For one, it's very difficult to train up external annotators to use Emacs. And even if you have a bunch of developers in-house doing annotation in-house, and there are good reasons for doing this, not all developers use Emacs. So therein lies the first tension of this talk, what we call programming in the large versus programming in the small. This concept was created in 1975, and in 2022, we're still not very good at solving it. So I want you to consider a program that is written in Spark, right? By and large, we can consider this a program in the large because it's going to run on many machines, a cluster of machines, and it's the kind of program that many people will touch, right? So the real result is that we have individual programmers who have to follow a rigid set of rules and run the clusters when they want to do and try something, right? It's quite hard to use when you compare it with immediately coding up a solution on your computer. The Spark ecosystem leaves very little room for personal sparks of creativity, which will often solve a problem in a much far superior way. So, the question is this: what do we prefer? Do we prefer to work within a rigid rule set that offers no creativity? Or do we want to work with personal flair, right?
Smells like a false dichotomy, but I don't know.
Hofstadter came up with individualistic cultures and collectivist cultures. And in the context of software development, in the context of data science and data engineering, we often have to choose a side. So what ends up happening is the data scientists will all code, with personal flair on their Jupyter notebooks, and the data engineers will come in and wrap the processors around that.
I have a friend whose job is literally this. That's what he complains about. Really? Like he works in a thing where there's data scientists who write Python code and blah, 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 and then his job is, he's like a computer science PhD. His job is largely making stuff like productionable and, stable and not made of jank, taped together.
Has been known to say that software engineering...
It's true, domain experts are terrible, terrible at writing software.
And this quote by Titus Winters, of course.
So it depends how you can, but they need to be able to
I don't think that has to be the case.
No, I don't think it has to be the case
That's
either.
one of the strong sides of APL, is allowing domain experts who are not really programmers to get their stuff done.
Right, but we still have, this is like the tooling, this is like the hard part of developing good tooling and stuff, is giving them just enough stuff to be able to produce what they want and deploy it in, the ways that are sensible, but not enough to give them lots of foot shooting guns left, right, and center. And write horribly unmaintainable things as their project scales.
I don't know if that's a solvable problem, but I certainly see in people that I help with things in APL, people who are domain experts and they're writing the APL code, and yeah, sure, I could polish it up a lot. But it's not terrible.
No, it depends,
It can be pretty good.
It also comes with experience, which everyone has to fight with anyway, right?
You're not.
Well, as they say, right? You're certainly not you're not born with the ability to write good, maintainable, scalable software, but it's often or generally a lot easier to take someone who has experience in the domain, knows all about that, teach them APL to get the job done, than it is to take someone who's an expert software engineer and not even teach them the domain, but just even translate the ideas of the domain, give them a spec that they can follow. It's difficult.
So it might not be the best code, but way better to get an actual product out the door that works and works correctly than having an continuously ongoing fight between the domain experts and the programmers that need to implement it, that don't understand each other, don't speak the same language.
Yeah. But you need a bit of both, the knowledge.
Right.
Some software discipline along with your domain expertise. Right. But you can get enough of that to be good enough.
Should we see what he has to say about this and then round it off?
Yeah, I think so. This is a quote that he's probably going to read out loud. Software engineering is programming integrated over time.
Maybe we should start with that for the next episode.
Very nerdy description. Yeah, if people aren't too turned off by this as a format, I think it was all right. I found this talk interesting, and actually, it was nice to go back and see it again and be refreshed of the things that are really cool about it, because it's a really nice talk in lots of ways. You know, as per usual, whether people see this as like a that was interesting and never this talk, I mean, people in the audience, and I never think of it again much, or whether it'll actually inspire people to go out and do and try things which are a bit off the beaten path. It's an open question, but hey, it's really nice to see people talking about APL who are not from the APL vendors, the typical places.
Yeah, for sure.
Or the once a year hacker news thread.
So for you as listener, if you don't want us to continue with looking at this video and others, then contact@apl.show is the place to complain. Otherwise, we might just continue.
All right, yeah.
Thank you for joining in then.
Yeah, thanks very much for listening and watching. And we'll see you on the next one.